Hi there, today we'll look at LeetCode problem. It's about to find the sum of array product of magical sequence. So first, let's go through the problem statement. Here we are given the two integer m and k and an integer array of nums. And a sequence of integer sequence is called magical if the sequence has the size of m and the sequence is in this range, like it should be greater than or equal to 0 and it should be less than nums dot length. And the binary representation of the 2 to the power sequence of 0 plus 2 to the power sequence of 1 so on up to 2 to the power sequence of m minus 1 has k set bits, and the array product of this sequence is defined as uh, so this is given the definition for the array product of this sequence, and from here we have to return the sum of the array product for all valid magical sequence. Since the answer may be large, you can return it in modulo, and a set bit refers to a bit in a binary representation of a number that has a value of 1. So this is the like this is the definition of a set bit. So basically in this problem, it asks you to find all the sequence of length m from the array, this nums array with all the possible repetitions, such that the sum of like 2 to the power sequence of 0 plus 2 to the power sequence of 1 up to 2 to the power sequence of m minus 1 has exactly k set bits in its binary representation. Okay, and for each valid sequence we will calculate the product of its element and sum this product, and we will return the answer in the modulo. So coming to the approach part, like first of all in this we will generate all the sequence of length m with repetitions using the indices of nums, and for each sequence we will calculate the sum of 2 to the power index for all indices in this sequence, and then we will check if the sum has exactly k set bits, and if as then we will calculate the product of the corresponding nums value and add it to the result. So coming to the code part, okay, first of all we will declare all the variable needed to solve this problem. Okay, so private int n m and k, and this, then private long private long char. Okay, like these are all the variables to solve this problem, and here we will create one helper function to count the set bits in binary representation. Okay, so this is the helper function. Let me comment that part. Helper function calculate like to calculate like set bits in binary. Okay, count bits int count will initialize with the 0, and like while this less than or equal to 0, count plus equal to x. And from here we will return the count, return count. Okay, now we will create one function that will recursively generate all the possible sequence. Like this function will recursively generate all the possible sequence. So private void DFS int depth here if depth equal to m. Like here then we will check if the sum has exactly k set bits, we will add the product to the result. Like if count bits of sum equal to k, then add the product to the result. Then result to result plus product. So this answer can be wrong, so this answer can be like big, so we will make use of this modulo. Okay, and from here like we will return start the recursion. We will make use of one for loop. For that, for int I equal to 0, I less than n I plus plus. Here we will make DFS of depth plus 1 sum plus and product to nums of I. Okay, modulo uh, mod. Okay, now this is our function. Here we will we have done this dot nums dot length, and this this dot equal to m, this dot k equal to k, and this dot nums equal to nums array. Okay, result 0, and let's start the DFS. Okay, from here we will return the result. Okay, now let's run and see this approach. Okay, this will be, sorry, yeah, here we have passed all the test cases. So like coming to this, how this working, like here the DFS, like it's this DFS function is like recursively building all the possible sequence of length m, and this sum accumulates 2 to the power index for each index in the sequence, and when the sequence is completed, it checks if the sum has the k sets bits, like if valid the product is added to the result modulo, and and from there we are returning. If not valid, it is going into depth and recursively searching for it.